This problem asks us what the temperature will be to make these two steel bars make contact. Currently they have a 1/100th of an inch gap in between them. They're both made out of steel. The bar on the right is 15 inches long, the bar on the left is 10 inches long. This is a thermal deformation problem. So we already know that thermal deformation is equal to alpha times the change in temperature times length. Okay, these are two bars made out of the same material, so the alpha in both cases is 0.00065 inches per inch per degree Fahrenheit. In this case, the temperature change that they're going through is both the same. Okay, the lengths are different, but you know the lengths. So when we look at this, we would be able to say, well, the deformation is equal to alpha delta t, length of the first steel bar, the 10-inch steel bar, plus the length in the second steel bar. Okay, what we're trying to solve for is delta t. We know deformation is 0.01. Okay, so we'd rearrange this to solve for delta t. Okay, and as we do that, we would find out that delta t is equal to 61.5 degrees. Now that's the change in temperature. This problem says that the temperature starting out is 80 degrees, so our temperature at which they'd make contact is 141.5 degrees. The second part of the problem says or asks, once they make contact, what increase in temperature or what temperature change from this point will you have the bars actually come under 1,000 psi of compression stress. Now in this one, you know that they'd be made of one material, so you do have a thermal stress equation which would say stress is equal to alpha delta T times E. All right, the E in this case is given as 30 times 10 to the 6th psi, so you can plug that in and you'd find out that that there's roughly about a 5-degree temperature change, and again you'd add that to the 141.5 degrees that you see on the screen.